Hello again. We are continuing our discussion of Algebra 1 by talking about properties of numbers. So let's begin. The first type of properties we're going to talk about are what things in algebra can be considered to be equal. Okay, so these are the properties of equality. We're going to talk about each property, how to write it symbolically, and then some examples just to show you what I mean. The first one is the reflexive property, and that basically says that any number is equal to itself. So 3 is equal to 3. And also any expression is equal to itself. 4 plus 5 is equal to 4 plus 5. Then we have the symmetric property, moving away from just talking about one number to talking about two numbers. So for any two numbers, if A is equal to B, then B is equal to A. And that goes for expressions as well. So if 5 plus 7 is equal to 12, then 12 is equal to 5 plus 7. Kind of obvious for those two. Then we get into the transitive property, where we're talking about three equal numbers or expressions. So for any numbers A, B, and C, if the first thing is equal to the second and the second is equal to the third, then obviously the very first thing is equal to the very last thing. They're all equal, but that's something that needs to be said as well. So an example is if 7 minus 4 is equal to 5 minus 2, which they are, and if 5 minus 2 is equal to 3, which it is, then 7 minus 4, which is the very first thing I talked about, would have to equal 3, the very last thing I talked about. So notice the number of items I'm talking about compared to the first letter in the name of each property. RST, reflexive, symmetric, transitive. Those are alphabetical order and they're right next to each other. And for the number of things I'm talking about, 1, 2, and 3. 1 for reflexive, 2 for symmetric, and 3 for transitive. So if you can remember that, then you can remember those three properties in that order. And the last one is the substitution property. If I know that two things are equal to each other, then one of them can be substituted in for the other in any expression that I want. So if x is equal to 5, then I know that 7 times x is equal to 7 times 5. X and 5 in that case would be interchangeable. They can be replaced with each other whenever you want. That's the substitution property. Then we have properties of identity. Okay, in every number system, we need something called an identity. And what an identity does is you can perform whatever operation it's associated with using that identity, and the value of what you're working with won't change. It's basically something that does nothing. That's what an identity is. So an additive identity, I need to have a number that I can add to anything and not have that value change. So in our case, it's 0. I can add 0 before or after any number, and the value of that number won't change. So for example, 5 plus 0, that's still 5. 0 plus 5, that's still 5. The reason I need that is because I need an additive inverse. I need to be able to have a number that I can add to another number so that it's the same as adding the identity or adding 0. So in our case, the additive inverse of any number is the negative of that number. The additive inverse of 7 is negative 7. The additive inverse of negative 2 is 2, and so on. Two things that add together to give that identity of 0 for addition. Then we talk about multiplication. I need to be able to multiply by a number so that the value of that number doesn't change. And in our case, that's 1. I can take any number, multiply it by 1 before or after that number, and the value of the number doesn't change. So 6 times 1 is 6. 1 times 6 is also 6. Doesn't change the value of that 6. And similarly, I need to be able to multiply two things together so that I get 1. So if you give me a number, I need to be able to come up with another number so that if I multiply your number and my number, we get 1 as the answer. So in our case, it's going to be what's called the reciprocal. It's going to be the upside down of that number. So if I have a over b as a number, all I have to do is multiply that by b over a, and I'm back to 1, whether I do it before or after the first number. So for example, if I start with 9/10, the multiplicative inverse of that is 10/9. And no matter whether I multiply before or after, I get 1 as the answer, which is the multiplicative identity. Then I talk about 0 because 0 is something that just can't be undone. If I multiply a number by 0 before or after that number, I will always get 0. There is no inverse for 0, so I'm kind of stuck. Okay, so 8 times 0 is 0, 0 times 8 is 0. That can't be undone. Okay, so let's talk about some properties of multiplication and addition. I'm going to talk about the property, symbolize it, and give you some examples. The commutative property basically says that anytime I have two numbers, I can add or multiply them in whatever order I want, and the answer will be the same. So whether I do a plus b or b plus a, I get the same answer. If I do a times b or b times a, I get the same answer. So 9 plus 8 is the same as 8 plus 9. 7 times 5 is the same as 5 times 7. The associative property works the same, but with 3 numbers. And so I've symbolized the order in which I'm going to add or multiply them by using parentheses. So if I add the first two, a plus b, and then I add c, that's the same as taking a and then adding whatever I got from b plus c first. So I can either add the first two and then add the third, or I can add the last two and add the beginning. Same with multiplication. So if I add 4 plus 6 and then I add 3, that's the same thing as adding 6 plus 3 and then adding 4. If I multiply 2 times 9 and then multiply that by 8, that's the same as multiplying 9 times 8 and then multiplying that by 2. So here's some more. These properties, I want you to note that these properties don't apply to subtraction. So you can't subtract or add in whatever order you want, but what you can do is you can add the opposite. So 7 minus 5 is not 5 minus 7, but what you can do is you can change 7 minus 5 to 7 plus negative 5, switch the order of those so that you get negative 5 plus 7. The answer to both of those is 2. So you can change subtraction to addition and then apply the property. Okay. Associative, 5 minus 2 plus 4 is not the same as 5 minus 2 plus 4. But if I change the minus 2 to adding negative 2, then the associative property works. Okay. Similarly with multiplication, if you want to use those properties, you have to change whatever you're dividing by. You need to change it to multiplication by the reciprocal. So 40 divided by 5 is obviously not 5 divided by 40, but if I change 40 divided by 5 to 40 times 1 over 5, then I can switch the 1 over 5 and the 40, and the answer is still the same. Similarly with associative, 48 divided by 2 divided by 3, I would need to change both of those divisions to multiplication and change the 2 and the 3 to 1/2 and 1/3 before the property will work. So it only works for addition and multiplication, not subtraction and division, but there is a way to change it if you want to use those properties. That is properties of algebra. And if you have any questions, please let me know, and I will see you tomorrow.